So using matrix functions in Excel is not very difficult, although it's sometimes a bit tedious. Matrix algebra is actually very helpful when we are discussing portfolio optimization problems. And so in order to help you with that, I'm going to briefly explain how it can be done. This is not going to be a mathematics class, so assume that you somehow had in a past class a little bit of exercise in matrix functions, and this should kind of refresh that a little bit. So the first thing to know is that matrix algebra simplifies notation, and that's why we're doing all this. So for instance, let's have a look at the equation for portfolio variance with two assets, or the standard deviation assets written down here on the slide. And as you can see, that is equal to the square root of 3 terms. Each term involves squares of weights and the square root of standard deviations, plus finally a cross correlation term involving the covariance between the two assets. Well, not a very lengthy formula though, but at least when we do it in matrix notation, we can write it down much more simpler using this equation where we have sigma squared is W apostrophe omega times W. And so W represents the portfolio weights. It's a vector of portfolio weights, and omega represents the covariance matrix. And the nice thing of matrix notation is that the formula is written down here doesn't change regardless of the size of the problem. So when we had free acid and writing it down in the usual way, we would end up with 6 terms and with 4 acids even more. And stop even thinking about 100 acids, we end up with something of over 5,000 terms, which would of course be impossible to write down in paper. And there matrix notation is helpful. Matrix notation is helpful for another reason, because we can also use it in software and for instance also in Excel. And so in order to be able to do that, we need a little background information. So we need to realize that matrix dimensions can be different. We can have square matrices like the 2 by 2 in the left top corner. We could have a column factor. We could have a row factor. We could have a 2 by 4 matrix, a 3 by 2 matrix. Anything does with matrices. And so, but it's important to notice, because when using matrix algebra, in particular in Excel, we need this information on the dimensions in order to figure out how large the outcome of the exercise is going to be and whether the exercise is possible at all. So let's first have a look at some matrix functions. So one of them is actually a pretty familiar one. I mean, you could do that in Excel already when you used copy and paste special. But that's the transpose function, which basically switches rows and columns. So the column factor 1, 2, 3 becomes the row factor 1, 2, 3. So nothing exciting about that. And Excel also has a matrix function called transpose. So that's very nice. Then there's some special matrices, and I kind of remember this as the identity matrix. It's basically the matrix equivalent of the number 1. And the identity matrix is simply a matrix which has only ones on the diagonal of the matrix and zeros on all the other elements. And of course there's also a diagonal matrix, but we don't use that really in portfolio theory, so I'm going to skip that one. Then the important operation that this one is one we're going to use a lot, and it's matrix multiplication. Essentially it's a summation of cross products, and as I said before, I'm not going to explain all matrix algebra. That would take at least a couple of lessons. But one important thing is that when you multiply two matrices like A and B in this example, the dimensions do matter. And so a typical way to write down the dimension is the number of rows for A, that's 3, and the number of columns for A, that's 4. And for B, the number of rows is 4 and the number of columns is 5. And so we write that basically like t times n and n times 1. And what is important in matrix multiplication is we can only multiply matrices when these inner dimensions, and by that we mean the number of columns of matrix A, need to match the number of rows in matrix B. And this will result in a matrix of the size t times n, also known as the outer dimensions. This is again important because as soon as you are going to use this in Excel, before doing anything at all, you first use the mouse to select an area equal to the size of the output of the operation. In this case, it is actually a 3 by 5 matrix, which is the output of this operation. So we're first going to do a 3 by 5 area selection before typing in the multiplication command. What does it do? Well, essentially, let's look at this output matrix. So the second row and the third column. What is that actually? That is basically 1 times A plus 2 times B plus 3 times C plus 4 times D. And this goes basically for all these elements in the output matrix. So before moving to Excel, you have to realize that matrix operations in Excel are part of a class of so-called array functions. So the array functions do not only apply, are not just matrix operations, but there are other functions too, like for instance the table function. And array functions all have the same property that before being able to use them, you first need to select the output in the spreadsheet, so the area. So you need to know beforehand how many numbers will come out of your equation. So you first select that, then you type the name of the function with all the proper arguments and so on. And you end the typing of the function not by pressing enter, but you press shift plus control plus enter. That's very important. And you need to practice this sometime because it is actually a bit annoying in use, and in particular in the first 5 or 6 attempts you will be frustrated a lot. Right. So the matrix functions that we are going to use in our course Portfolio Theory are in particular the commands matrix multiply. So that's the slide that we just discussed about multiplying two matrices. The transpose function, and also a very useful one is the matrix inverse. In the matrix inverse only works on square matrices, so where there's an equal number of rows and columns. So let's have an example. Let's look at the matrix multiply command. So suppose that I want to calculate the portfolio return using the matrix multiply function, and I have data organized with weights from in cell B2 to D2, and the returns are in column B5 to B7. So I could put my cursor on D6 and then realize that the output of this operation is a single cell, so I only select a single cell. Then I type matrix multiply, MMULT, and then I have B2 colon D2, which are the weights, semicolon B5 colon C5 in cell D6, and I conclude with shift control enter, and then we end up with a return of 12.4%. So my invitation to you is try this at your own computer and see whether you can replicate it. Take care with these matrix multiplications. As I said before, you cannot multiply any couple of matrices. So if you find errors, check whether you could actually do it. Check whether the inner dimensions need match. So the number of rows from the first argument need to match the number of columns from the second argument. And before typing the matrix function, figure out the size of the output matrix. Well, let's move to the transpose function. Well, that's kind of another trick, you know. So let's continue with the previous example, and now let's assume that we want to have the weights in a column vector rather than in a row vector as it is in the example. So the way to do it is select the range C5 to C7, then type transpose B2 till D2 and conclude again with Shift Control Enter, and you will nicely get these numbers. So that's transpose. Well, we can now use the tutorial preparation questions 1 and 2, and I leave that up to you for trying that. Here you can see the answers for question 1, so you can check here whether you've done it right. And here you have the answers for question 2, so that may also help you in resolving this. This finishes the exercise, and I hope this helps you in preparing for the class.